Morning.
Morning, Cha.
Hello.
Hi. Morning.
Morning, Cha.
Okay, so the past year paper that I uploaded last week, the answers have also been uploaded. I hope you all have marked it already. If you have any questions on it, we will do it at the end. What we're going to do today is we're gonna do this paper during class, and I'm gonna give you 1 hour 15 minutes. So we're gonna time ourselves, and we're gonna do the paper. So today's paper we're gonna do is paper 4, October November 2017, variant 4.2. So I will start the timer maybe around 9:10. I'll just wait for a couple more people to come in, and then we'll start the timer, and I'll give you all exactly 1 hour 15 minutes, and then we will stop, and then we will see how we did that. Okay, everyone understand?
Yeah, sure.
Yeah. Does everyone have the hard copy of this in your pile of exam papers?
Yeah, Cha. I think.
Uh,
Let me just look.
Yeah. Y'all haven't done this paper yet, right? Can y'all just check?
Okay, Cha. Give us a sec.
Check and see if y'all have done it already or not.
What's the year again, Cha? Oh, never mind.
October, November.
Two 2017.
Teacher,
Yes?
I have done this paper.
You've done this paper.
Yeah.
Okay. Anyone else have done this paper?
I can't remember we did this, sir.
We did this?
Me, teacher.
Done already.
Yeah, sure.
Another paper then. You all done this one? October, November 2018, variant 1.
October, November 2018.
No, sir.
No?
No.
Okay, then let's do this one. Anyone else? Anyone has done it?
I don't think so, sir.
Okay. If that's the case, we will do this one. Anyone needs the soft copy and wants me to send it on WhatsApp to the group?
Teacher.
No? Do you want me to do that? Or do you?
Teacher.
No, okay. Okay, CK not here. Daman? Daman, are you here? Yes, I heard him just now. Okay. Edmund? Kezia?
Here, teacher.
Justin? James?
Yeah, sure.
Ika?
Here, teacher.
Mushiga?
Oh, teacher, I'm Mushiga.
Nikita? Nikita not here. Cedric?
Yeah, sir.
Nazri?
Here, teacher.
Yonghong? Here. Zinia?
Here, teacher.
Daman, can you hear me?
Yeah, can, sir.
Okay, so CK, Edmund, Justin, Nikita, and Yonghong not here. Does anyone know what happened to CK? Apparently he was in the hospital.
No clue.
Okay, just give me a moment to write his names in the group. And I will... Okay. So, does everyone have the paper with them?
Teacher.
Yeah. Okay, so it is. Okay, it's 9:18. I'll wait for 9:20. Then we'll start. So it's a 1 hour 15-minute paper. 1 hour 15-minute paper. So we'll start at 9:20. We will finish at 10:35. Okay. Make sure you have the correct paper with you. These are the questions that you should be looking at. They're all together. Let's see how many questions. They're all together 11 questions. Okay. Okay. Okay, you can start now. You'll finish at 10:35. Okay, come. Did you all manage to finish the paper?
Yeah.
Huh?
True.
Managed to finish, huh?
Yeah, Chair.
Okay, was it very rushing, or was it just nice, or it could have used more time, or how?
That's nice.
Just nice. Okay, so this is paper 4. Paper 4 is 1 hour 15 minutes. Okay. I have posted the answers on Edmodo. Y'all can go and mark your work, but there are some questions I just want to go through with y'all before we
All right.
for the day. Let's look at question 11. Okay, question 11, figure 11.1 shows data about 9 elements. Okay, carbon 14 is a radioactive isotope with a nucleon number 14. It decays by emitting beta particles. Use data you need from the figure to write down the nuclear equation for this decay. So how would you do that? What would your equation look like?
So like C in like 6 and 14.
Sorry?
Then the arrow.
Wait, let me just switch to my whiteboard and then I will write as you speak. Okay. So what was it again?
So like C and then like 6 and 14 with the number on the side.
Okay. 6, 14, correct?
Yeah.
And then?
Then the arrow.
Okay.
And then like B.
As in this
So I
one?
think. Yeah.
Okay.
And then like -1 and 0.
Okay. So what will my element after it decays will have, what's the proton number? What will the proton number be?
7.
Nuclear
And
number
then 14.
14.
And
And yeah. So based on the table given, okay, 7 is nitrogen. So that's why we put an N. So that means the carbon has decayed to nitrogen. Okay, anyone has any questions on that? Any confusion?
No, Chair.
Nature.
Okay. Let's look at another one. Okay, let's look at number 10. I have a transformer consisting of 2 coils of wire around a metal core. That figure 10.1 is the transformer. State the name of the metal from which the core is made.
Soft iron.
Yeah, so soft iron. So 10A is soft iron. Okay, let's look at B. The primary coil of the transformer is connected to the output voltage of AC generator, which supplies an alternating current. Explain why is there a voltage between the two terminals of the secondary coil. Why is there a voltage between these two terminals of the secondary coil?
One to go in, one to go out.
Sorry?
One to be go in, one to go out.
Not quite. Because going in is primary coil. Output is secondary coil. So look at the question before B1, the statement. The primary coil of the transformer is connected to output voltage of an AC generator. And this AC generator supplies alternating current. So, based on that statement, so when they give you a statement like that, they're expecting an answer that is related to that. That's how they ask questions, essentially. So, based on alternating current, why is there a voltage between the two terminals of the secondary coil? What does the alternating current cause?
Magnetic field.
The alternating current causes magnetic flux, magnetic field in the secondary coil. Okay? And that's when the voltage is induced here because of the change in because of the magnetic flux. That's why there is a voltage here in the secondary coil. Okay? So you want to mention, so there are 3 marks there. So the first mark is there's the alternating current from the primary coil. Okay? That causes the magnetic flux in the secondary coil. That's the second point. And then the third point is voltage is then induced in the secondary coil. Okay?
So can you repeat that?
Yeah, I'll write it down. So there are 3 marks there. So there's alternating current, the primary coil, alternating current causing magnetic field in the primary coil. Okay. Then this causes change in flux. Magnetic flux. The secondary. Voltage is then induced in the secondary. This is essentially how a transformer works, okay? That's how the voltage in secondary coil is induced. Because of the alternating current from the source in the primary coil, that causes magnetic flux in the secondary coil. So when there's a magnetic flux, a change in magnetic fields, voltage is induced. It's like the AC-DC generator, same concept. There is a change in current. Current keeps changing back and forth. That causes the magnetic flux. And that's how the voltage is produced, because there is a change in the magnetic flux. There's a change in magnetic field. So the voltage is induced because of the change in voltage, the change in magnetic field. Okay, let's look at the next one. Okay, there are 560 turns on the primary coil and 910 turns on the secondary coil. The voltage between the two terminals of the secondary coil is 78 volts. What is the voltage supplied by the AC generator? That means voltage supplied by, if the voltage supplied by the AC generator means, that means at the primary coil. So what do you all get? What answer do you all get?
48.
48, yeah, we should get 48 volts. So it's the ratio between the primary voltage and secondary voltage, and you equate that to the number of coils in the primary and secondary coil. Okay, so you should get 48 volts. Everyone got 48 volts? Anyone did?
Yeah, sure.
Gotcha.
Okay. Okay, let's look at the last one. Transformers are used to increase the voltage when electrical energy is transmitted in cables across long distances. Explain why power losses in the cables are lower when the voltage is high. So why when the voltage is high, the power loss is lesser? Why is it that when the voltage is high across the cable, so this is like electricity coming into your house, it goes through the tower and then it passes through the cables, long distances, and then it comes to your house. So why is it that when the voltage is high, the power loss is much lesser? Which is a good thing, that means it's efficient, but why is it such? Why is it when the voltage is high, the power loss is low? What happens when the voltage is high? When voltage is high, what component changes?
The resistance.
Before the resistance, what changes?
Current.
Current.
Okay, what happens to the current?
The current.
When voltage is high, current is?
High.
Low.
No, low. When voltage is high, current is low. So when current is less, automatically my power loss is also less. Why? Because why is it that my power loss is lower? Is because P is equals to I square R. So lower current would mean less power loss. So lower current, low heat loss. Low heat loss, low power loss. So based on the, let me switch back. Based on this formula, P equals to I square R. When P is, let's say P is power loss. Okay. When voltage is high, current is low. Sorry, voltage is high, current is low. Okay. So when current is low, this is low. Okay. And this is lower current, my power loss will also be low. Another concept is because when current is low, heat loss is also lower. When heat loss is lower, power loss is also lower. Okay, can you understand?
Yes.
Okay. Do y'all have any questions so far?
No.
No? Okay, it is 11 o'clock now. I will post the answers on Edmodo. So y'all can check. If y'all have any questions on this paper, you can message me now on Edmodo or on WhatsApp as well.
Okay, teacher.
Yeah?
Teacher.
Okay.
Yep.
That is all for today.
Okay.
Bye, sir.
And,
Thank you, Chair.